Okay, today we're going to talk about Unit 2, Lesson 3, because it is freaky for me. Today we're going to talk about, for the second time, Unit 2, Lesson 3, linear functions. We did a lot with lines. We've been talking, and we've had a lot of IXL standards about lines, slopes of lines, y-intercepts of lines, but we want to make sure that we verify the two different ways that I can rate a linear function. We talked about functions enough last year in Algebra 2. So Form 1 is the slope-intercept form of a function. But keep in mind, this is f of x, and I've solved for y. F of x equals mx plus b. 0b is the y-intercept of the linear function, and m is the slope. This is the point-slope form of the linear function. Oh, two forms. This is the point-slope form, and we're going to talk more about the point-slope form. And if you look over at this is a prevalent linear function in calculus. This is what we use in calculus all the time. This is the equation of the tangent line. That's nothing more, nothing less than that point-slope form of a line. Both cases, m is the slope of the graph of the linear function. M is the average rate of change of the linear function. So m is the average rate of change of linear function. Note, the average rate of change of linear function is constant, the constant m, and can be hard to describe verbally. This is one that's going to be hard to describe verbally, but the verbal description is very important. The verbal description of this average rate of change: for a single x unit, the function increases or decreasing, whatever the case is, my units. Okay, here's some basic properties of both forms of linear functions. The domain is all real numbers. If m doesn't equal 0, the range is all real numbers. If m is equal 0, then the range in Form 1 is y is equal to b, and in Form 2, y is equal to y sub 1. Because if m is equal to 0, m times x minus x sub 1 is 0, and I have the range is going to be y equals y sub 1, and here if m is 0, 0 times x is 0, and I just have b. So that's going to be our constant function. We'll talk more about that constant function later. I think Stickman alluded to that. A linear function will have no minimums and maximums. If m is greater than 0, then the graph of the linear function increases over its entire domain. If m is less than 0, the graph of the linear function decreases over its entire domain. If m is equal to 0, then the graph of the linear function is constant over its entire domain. Heavens to Betsy, we talked about that when we talked about linear equations and graphs of lines and slope-intercept form, point-slope form. A vertical line in the Cartesian coordinate system given by the equation x equals a, where a is any real number, is not a linear function, but it is an equation. And here's an example of an x equals a. If I can take this guy right here, maybe I can, hopefully I can. Yeah, there I go. That's going to be x equals a. A can be positive. Whoop. A can be 0, which is the y-axis, or a can be negative. Whoop. All righty. Consider a linear function in form number 2. F of x equals negative 2 plus 1/3 x minus 5. I want to pull that line out of there. He's bugging me. Get him out of there. Name the domain. Well, the domain of all linear functions is all real numbers. There's a couple different ways you can write that. You can do set builder notation if you want. X is all reals. Name the range. The range of this, m is not equal to 0, so the range is all reals as well. This is going to be really easy in linear functions, not so easy when we talk about quadratic functions or rational functions. or square root functions, or trigonometric functions. But we're going to do this, we're going to do all of these topics for linear functions. Okay, find and give the y-intercept as a point. Well, the y-intercept, if I put x equals 0, what do I have here? Let's erase that little booger. Oh, he's made with lines, isn't he? Let's just get him out of there and get him out of the picture. Okay, find and give the y-intercept as a point. How do I find the y-intercept? I let x equal 0. So I'm going to let x equal 0. And if I put 0 in for x, what do I have? I get y is equal to -2 plus 1/3 times -5. So that's going to be -2. Running out of room over here, but I can manage. That's going to be -2 minus 5/3. 5 times 1/3 is -5 is 5/3, positive, negative, negative. So that's going to be -6/3. Check my arithmetic on that. I believe that that is going to be -11/3, is it not? 6 minus 5 is 11. So the y-intercept of a point here as a point is going to be right here. I'll plot that bad boy right here. 0, -11/3. And if I find and give the x-intercept as a point, the x-intercept, I'm going to do him down here. X-intercept, I'm going to let y equal 0. This is going to be very important with all the following functions, all the different functions that we're going to study. X-intercept, I'm going to let y equal 0, so I'm going to solve this equation right here. For x, I'm going to add 2. I would not distribute this 1/3. It's better to get rid of the 1/3. I think you should have room in your textbook. By multiplying both sides by 3. And that gets rid of that 1/3. So this is 6 is equal to x minus 5. Add 5. 11 is equal to x. So therefore, the x-intercept is going to be, I'm going to plot this rascal there. It's going to be 11, 0. 11, 0. Find and explain the average rate of change of the linear function, and I have this one given for you. On average, for each x unit, the function increases 1/3 y units. Given that for you. Okay, that was a function given in form 2. Finding the x-intercept, y-intercept, domain, and range. Let's go to the next example here. Is that the next example? Okay, linear function f of x is positive, f of x greater than 0 for all x values where the graph of x, f of x, is above the x-axis. So it's going to be negative. The function is going to be negative. All those function values, because the function values, don't forget that y is equal to the function values. Y is the output. F of x is the output. All of the outputs are less than 0. When f of x is below the x-axis, the outputs or y's are greater than 0 when f of x is above the x-axis. So let's look at our example. Consider the graph of some linear function and find the following. The x scale is 1 unit, the y scale is 1 unit, the x-intercept is 3, 0, the y-intercept is 0, -2. Where the function is positive, and explain why. Here's your explanation. So where is the function positive? F of x. Positive means greater than 0. When you are correct, Billy. F of x is greater than 0 when, and we can say it 2 different ways. When x is greater than 3, or you can, let's get that little guy out of here, that little purple guy, he's freaking me out. When x is greater than c, or you can say on the interval, 3 comma positive infinity. That's where y, here's the y, since the graph of x is what? Is above the x-axis. There. It seems like a very simple explanation, but it is an explanation nonetheless, and a correct explanation. So f of x is above the x-axis when x is greater than 3. And the graphical representation, here's your x, 3. For all of these x's greater than 0, or all those x's greater than 3, the function values are what? Greater than 0. That's what that means. Okay? Where the function is negative, and explain why. Where the function is negative, explain. Oh, okay. Okay, f of x is less than 0 when x is less than 3. Or you could talk about interval notation. It doesn't matter. This is set builder notation. I could go set builder notation or interval notation, and the interval notation would be negative infinity, comma 3. Why? Since the graph of f of x is below the x-axis. There. Find and explain the average rate of change of this function. So the average rate of change of this function, let's see here. What is the slope of the line? So the average rate of change, first thing we're going to do is find the slope m of this line. And this line was given graphically, not analytically. So we're going to use stickman method to find the slope. The slope m is simply going to be up 2 over 3. The slope is 2/3. And we want to make sure we write the average, or the verbal explanation of the. And so look what I'm going to do. I'm going to go back here to this next page and make sure I'm going to copy it down. I'll make it really easy. I'm going to use this format. Okay, how do I explain the average rate of change? On average, for each x unit, the function increases blank y units. On average, for each x unit, a y'all bolt. On average, I don't like when that happens. On average, this is positive, 2/3 is positive. The function increases. How did I write that? I'm getting mixed up here. I want to follow the model. On average, for each x unit, on average, each x unit increases how many y units? 2/3 y units. Okay, so let's name the function. On average, each x unit increases 2/3 y units. Name the function, give the rule using form number 1. So form number 1 is simply the slope-intercept form. Form number one, I'm going to write it down, mx plus b. I know b from the graph, and I know m. So m is going to be right here, -2, and the slope is 2/3. So this is going to be an easy one to write. It's going to be 2/3 x plus -2. Or you can just write -2. Doesn't matter. Find 2 points not given on the graph of the function and name the function using form 2. Well, it's going to be easy. I'm going to use, let's use 6. Let's put 6 in for x. Let x equal 6. Y is going to be 2/3 times 6 plus -2. 2/3 times 6 is going to be 4 minus 2 is 2. So that point is going to be 6, 2. Okay, so I magically came up with these 2 points, x equals 6. I used 6 since it was a multiple of 3. 2/3 times 6 is 4, minus 2 is 2. And then I used and magically used 9. 2/3 times 9. 9 is 3 times 3. One of the 3's cancel. 2 times 3 is 6. Minus 2 is 4. Now I have 2 points, and I can actually write 2 versions of form number 2. And the first version I'm going to write, I'm going to use the first point 2 plus the slope was 2/3. The slope does not change. X minus 6. Another version of form 2 is going to be 4. Using this 4, 2/3 times x minus 9. Okie dokie. And both of those, if I did the mathematics, if I did the arithmetic, they both would equal this guy right here. 2/3 x minus 2. Let's see what the next thing okay. So now we're going to look at when linear functions and inequalities. Linear function and inequalities continue. Any function f of x is greater than another function g of x, i.e. f of x is greater than g of x, for all x values where the graph of x is above the graph of g. So if I ask a simple question, where f of x is below, I'm going to look, if I want to know where f of x is less than g of x, right here, I'm going to look to see where f of x, the graph of f of x, is below the graph of g of x. So I'm going to consider these two linear functions, 2/3 x minus 2 and -1/6 x plus 3. This guy here, and I'm going to label them. This guy here has to be f of x because it's the only of the two lines with a positive slope. So this is f of x. I'm going to label that rascal. And this guy here has to be g of x because it has a negative slope because Stickman is walking downhill. So this is going to be g of x right here, which is going to be -1/6 x plus 3. And so I've graphed both functions, and I want to find out where f of x is above g of x, i.e. I want to know where the red, it's color coordinate, where red is above blue. Well, when is red above? And we're going to think about x intervals. We're going to think about x. So I'm going to run my pen along the x, and you tell me, is red above blue there? No. Red above blue there? No. Red above blue there? No. Red above blue? No. Red is equal to blue, but right here, look at this. If I go above that x value, what's going on? The red is above blue. So I need to find this x value right here. How do I find that x value? What's going to happen there? How do I find that x value? I find that x value by starting to solve the system of equations. So what I'm going to need to do is figure out where those graphs equal. So I need to solve this problem. I need to know where f of x is equal to g of x. So I need to solve this equation. 2/3 x minus 2. Where does that equal? -1/6. X plus 3. We did a lot of this as an algebra 1 equation. I'm going to multiply both sides of that rascal by 6 to clear the fractions. So 6 times 2/3 is 4. Looks like I have here 4x minus 12 is equal to 1/6 times 6 is 1, negative x plus 18. If I add that x over there, if I add the x, it looks like I'm going to have 5x. I'm going to add the 12 is equal to 30, and that says x is equal to 6. So now I have that x value. Where is f of x greater than g of x? F of x is greater than g of x. Here's the solution. When x is greater than 6. Why? Since the graph of f of x is above. This is the part that math students do not like. They do not like this writing. So f of x is greater than g of x when x is greater than 6, since the graph of f of x is above the graph of g of x. There. Okay, what I'm going to do now is I'm going to pause the video